Welcome back to another Algebra 2 lesson. This time we're going to go ahead and take a look at the QM.2 notes, where we are actually going to review some concepts that we had from Algebra 1. The entire unit of QM is quadratic methods that we're going to use with quadratic functions. So we took a look at imaginary complex numbers, which may be new concepts. And now we're going to look at a review concept of factoring that's going to help us as we progress into quadratic functions. So factoring, specifically polynomials. Before we begin, let's look at a couple of definitions. So our first section is the greatest common factor. So we are going to factor polynomials using the greatest common factor. In order to do that, we should cover what a polynomial is. A polynomial is an expression with more than one term. So as you guys talked about in Algebra 1, you probably talked about binomials that we see here in 1a with two terms as the expression. Trinomials, which we see here in 1c with three terms in the expression, and maybe even polynomials with more than three terms. All of these are classified in general as polynomials, expressions with more than one term. So we can classify polynomials by the number of terms they have, a binomial or a trinomial, etc. We can also classify them by degree. So the greatest exponent. So this in 1a would be degree 4. In 1b, degree 5. In 1c, degree 2. So you guys probably talked about all of those things in Algebra 1. But we just want to make sure we know what a polynomial is. So we are going to factor these polynomials. And the first method that we are going to use is the greatest common factor. The greatest common factor, or what we also often refer to as the GCF, is the highest value that divides each term of a polynomial. So we're looking for a single value that's going to divide every term of the polynomial. And that's what we're going to use in problem number 1 to factor. So in 1a, we want to factor by finding the GCF. So the GCF is the greatest number that divides each term. Take a look at 6x to the 4th. 6 can be divided by 2 and 3. It can also be divided by 6 and 1. X could be divided by, x to the 4th could be divided by x, x to the 1st, x to the 2nd, x to the 3rd, and x to the 4th. 8 can be divided by 1, 8, 2, and 4. So out of these two terms, the things that could divide 6x to the 4th and the things that could divide 8, what's the largest number that they have in common? If you said 2, then you were correct. So 2 is the GCF for each of these terms. So what we would do in order to factor this is we would factor out a 2. Basically, we are reversing the process of distribution. So if I take a 2 out of 6x to the 4th, or essentially if I divide 6x to the 4th by 2, what I have remaining there would be 3x to the 4th. So in parentheses, I'm going to have 3x to the 4th plus, now if I divide 8 by 2, what I have remaining there is 4. And so what I have done is I have factored this expression by taking a 2 and essentially removing it from each of the terms. Now we can check that by multiplying. So if I multiplied and distributed, this would be 6x to the 4th plus 8. So this is expanding or multiplying, and then going in this direction is factoring. And what we are focusing on right now is factoring. So we're looking initially for the GCF. Now let's take a look at 1b. The GCF there is going to be slightly different. So each of these are variables. Variables with a power can be divided by any value that is the same variable with a lower power. So x to the 5th can be divided by x to the 4th, x to the 3rd, x to the 2nd, and x to the 1st. X squared could be divided by x to the 2nd or x to the 1st. So what do they have in common? What's the highest number that they have in common? If you said x to the 2nd power, you'd be correct. So this would be x to the 2nd. Now, if I took away an x to the 2nd from x to the 5th, let me just do a little refresher on exponents. x to the fifth would be x times x 5 times. And then if I divide by x squared, that would be x times x. And I can cancel here. What I would have left over is x times x, or x cubed. Now, you definitely wouldn't need to show this down here on the bottom, but that's the thought process we're going through. So if I'm factoring out an x squared from x to the fifth, I'm left with x cubed. If I'm factoring out an x squared from x squared, I'm left with 1. So the GCF for those two terms would be x squared, and what I would have remaining would be x cubed plus 1. Let's look at C. So in C, I want to find a GCF for all three of these terms. Let me first look at variables. So the first term has an x squared, the second term has an x and a y, and the third term has a y. So none of these three terms have the same variable in common for each of them. So a variable is not going to be a part of our GCF. Now we have to find numbers that could divide 12, 18, and 30. Remember, if you don't remember what they are right off the top of the head or your head, you can use a calculator. I could type in y equals 12 divided by x, look at the table, and any whole number paired in the x and the y column would be factors of 12. So 1 and 12, 2 and 6, 3 and 4. So out of those numbers, 1, 2, 3, 4, 6, and 12, what's the largest number that also could be a factor of 18 and 30? If you said 6, then you'd be correct. So what we can factor out here in this case is 6, no variable. So the first term would be 12x squared divided by 6, so just 2x squared. The second term I would be dividing 18 by 6, so positive 3xy. And the third term I would divide a negative 30 by 6, so negative 5y. And so this is how we can use the greatest common factor to factor expressions that's going to allow us later on to help solve. We will always look for a greatest common factor first. Okay, so that one should be very familiar to you. Another technique that we have is what we call factoring by grouping. Factoring by grouping relies on one key idea, that if we have two coefficients for a binomial that is the same, so this binomial is x plus y, we can combine those coefficients into another binomial. So if I have a times x plus y and b times x plus y, then I can take that and rewrite this as a plus b times x plus y. And this is where we're going to go under the assumption that a, b, x, and y are all real numbers. So no imaginary numbers in this concept yet. So this is primarily going to be used for polynomials with an even number of terms. So if you take a look at a, 2a, there's 4 terms, and 2b, there's 4 terms. We're primarily going to try to use this when there is an even number of terms, 4, 6, 8, so on and so forth. With 2 terms, there's no need to group. So a polynomial with more than 2 terms that's going to have an even number of terms. What we want to do in the process of factoring by grouping is we want to first group terms with a similar GCF. So that concept of GCF is going to stay with us here. So if I look in 2A, I might take a look there and I might see that I have x cubed and 3x squared. They could have a similar GCF. And I have 5x and 15. They could have a similar GCF. So I'm going to initially pair those together. The second thing that I'm going to do is factor each group using the greatest common factor. So if I look here in the first group, I have x cubed plus 3x squared. My greatest common factor for that should be x squared. And so that leaves me with x plus 3. In my second group, I have a 5 that could be the GCF, and so I factor out 5, and that leaves me with x plus 3. So we're using that idea of the GCF to kind of rewrite this expression. Now, if this meets the key idea that we listed above, we want to rearrange the terms. And that's according to that expression that we showed above, that rule. So the two coefficients, x squared and positive 5, are going to come together to be a factor with x plus 3. So basically what we're doing here is we're reversing the process of distribution. If I were to distribute, I would take x squared plus x and x squared times x and x squared times 3, which is what we list here. And then I would do the same thing with 5, which is what we list there. So what we're doing here is reversing the process of distribution to give us a factored expression of what we saw before, a polynomial with 4 terms. And so this would be my final answer. Sometimes you do need to rearrange the terms to get them in appropriate groups, but often you don't. So let's go ahead and take a look at B. I'm gonna group again first in B. I'm gonna group this 3x cubed and that 15x squared together. I'm gonna group those together because I see that they have a GCF of 3x squared. I'm gonna group the second term together as well. Now notice that I have that negative inside the parentheses. So I'm going to put a little plus sign here because there's an addition of these two groups. These two groups are not being multiplied. So for my first group, I want to factor out the GCF. My GCF is going to be 3x squared, which would leave x plus 5 in parentheses. My GCF for that second group is going to be a negative 6. Notice they both have negatives, so I'm going to factor out that negative value. That would leave me with x plus 5. Now, the key thing is we're looking inside those parentheses. Because each of those binomials are the same, I can factor out, or I can combine their coefficients as a factor. Now, notice something that I didn't do right away that I probably should have done or could have done, but means I'm not finished at this point. Initially, if I'd have looked at this function or this polynomial, I would have noticed that each of the terms has a GCF. That GCF is 3. So I probably should have started by factoring out the GCF. If I didn't, that's okay, because down here, notice in this set of parentheses, they have a GCF. So because I've learned this operation, I do want to be able to factor out the GCF. So I'm going to factor out the GCF of 3x squared minus 6, and that would leave me with x squared minus 2, and then x plus 5 would be left alone. So I do want to fully factor this based on the skills that we have right now by taking out that GCF. You can do that in the beginning, or you can do that in the end. Let's go ahead and take a look at another example of grouping. If you get the process, go ahead and pause the video and see if you can complete C and D. If you don't yet, let's take a look at C. So in problem C and problem D, we want to factor this by grouping. So the first step again is to group or rearrange terms into two groups that have a similar or the same GCF. So my first group that I can put together is r cubed minus 2r squared. And my second group together I'm going to put is negative 3r plus 6. Notice that I have that negative inside the parentheses there. So I'm putting the positive in between my groups to remind myself that this is not multiplication, this is addition of terms. Now, GCF. So the GCF for my first group is r squared, and that's going to leave me with r minus 2 inside that first group. My GCF for the second group could be 3, but I'm going to go ahead and take out a negative 3. The reason I'm going to take out a negative 3 is when I do that, I get r minus 2, which that matches up with the first binomial that was in parentheses. If I took out a positive 3, which could have been okay, you could have done that. So let's just take out a positive 3 with the second group because that is a GCF. I would get negative r plus 2, which I would not be able to rewrite these because inside the parentheses, we need those binomials to be exactly the same. So what I'm going to go back is make sure that I factor out the negative It's nice to always have your leading coefficient in that binomial to be positive. That makes it a little easier to see the pattern there. So now, because I have binomials that are the same, their coefficients are going to be a factor, as well as that binomial is a factor. And so I get r squared minus 3 times r minus 2. And that's where we're going to stop for now. Eventually, with this problem, sorry. Eventually, we are going to be able to factor that a little bit further, but for right now, our skills are sufficient to get us here. If you have not yet done D, go ahead and pause the video and see if you can complete D. Hopefully, you've taken the chance to do complete D. What I may notice here when I look for originally is I may look at, see, each of these have a coefficient that's a number. So I might look for a GCF first, but I don't see one. So I'm going to go in the process of grouping because these are an even number of terms. It's got 4 terms here. I'm going to group the first 2 and the last 2. Now, you did not have to group it that way. But if I did group it that way, my GCF for the first 2 is going to be x squared. And then parentheses, I would be left with 3x plus 2. And my GCF for the second part is going to be negative 9. And in parentheses, I'm going to be left with 3x plus 2. And now I notice that I have 2 binomials that are the same in the parentheses. So their coefficients are factors. So then I would rewrite this as x squared minus 9 times 3x plus 2. And there we have the final answer. Now again, eventually we're going to learn a little bit more information. And we're going to go a little bit further there. But for right now, that's a good place to stop with a factor. So this is a good place to stop this first video. Here we have gone over factoring using the greatest common factor and factoring by grouping. Those are 2 of the about 5 or 6 methods that we are going to have of factoring polynomials. When we reconvene in class, we'll have the opportunity to practice some of these skills, and then we're going to go a little bit further in those QM.2 notes, exploring some other methods of factoring. Thank you guys for tuning in, and I'll see you soon.